Hello everyone, my name is Arbelfi, and in this video we are going to continue the subject ions. And so these are the main subjects for this video, and so without any further ado, let's get started with our video. Okay, so in the previous video we left off at the part of the sodium and chlorine ionic bond. Okay, so let's continue from there. So if you had watched my previous video, I talked about some atoms that are so different in their electronegativity that one of the atoms strips an electron or two from the other atom and they form an ionic bond. So one real example is sodium and chlorine. Okay, so we know that these are the pictures of the atoms sodium and chlorine. Okay, and as you can see, sodium has only one valence electron in its valence shell, and so that it can be or so that it can get or be happy, it can also lose one electron and or gain 7 other electrons. Okay, and we know that losing one electron is easier than getting 7 other electrons. Okay, so the sodium has a natural tendency to lose one electron. Okay, but in the other hand, chlorine has 7 electrons in its valence shell, okay, as shown in this picture, and so it can be happy by two ways: one, by gaining one electron, or two, by losing all the 7 electrons. Okay, so it's easier to get one electron than losing 7 of them. Okay, chlorine has a tendency to gain one electron. Okay, so here we can see that phenomena taking place. Okay, so sodium, as this arrow shows, loses one electron to chlorine. Okay, and so chlorine gets a partial or one negative charge, and sodium gets a positive one charge. Okay, because it has lost an electron and chlorine has gained the minus charged electron. Okay, these plus and minuses attract each other, and so the sodium and chlorine come together and form sodium chloride. Okay, and as you should know, sodium chloride is the same as table salt that we use in the kitchen. Okay, so have that in mind, and so let's continue. Okay, so compounds that are formed by ionic bonds are called ionic compounds or salts. Yes, and you heard me right. They are called salts. Okay, and an example would be the compound sodium chloride. Okay, or as I told you, the table salt. So in conclusion, we have so many different kinds of salts, some which may not be good for the human body and be toxic to the human body. Okay, so in this picture you can see some examples of these salts. Okay, these salts are made from different atoms, not just sodium chloride, and if you look closer you can see those elements written on the glassware. So salts are often found in nature as crystals of various sizes and shapes and colors. Okay, and each salt crystal is an aggregate of vast number of cations and anions bonded by their electrical attractions and arranged in a three-dimensional lattice, okay, or shape. Okay, and unlike a covalent bond, ionic bonds don't consist of molecules. So the formula for an ionic compound such as NaCl, okay, or sodium chloride, indicates only the ratio of elements in a crystal of the salt. Okay, so in conclusion, sodium chloride, okay, is not by itself a molecule. This is the picture of table salt, and as you can see, only this part, okay, which I am showing by the mouse, okay, or arrow, okay, this part is cloned, okay, in this one. Okay, so this is a block, a little very small block of salt. Okay, and so sodium chloride, which is over here, as you can see, is cloned into this giant part. Okay, and sodium is big here, but it is small here. Okay, so why do you think it is like that? Okay, and I'm sure I didn't make a mistake. Okay, so the sodiums, okay, have one electron, and so they have three, I think, valence shells. Okay, but when the sodium atom loses that one electron, it loses that valence shell as well. Okay, and that causes the atom to get smaller. Okay, and the chlorine, which, as you can see in the left part, is small, gets bigger. So that's because it gains an electron. Okay, and actually just fills its third valence shell, and that equals it by getting a little bit bigger. Okay, in diameter. Okay, and so not all salts have an equal number of cations and anions. Take for example magnesium chloride, or MgCl2. Okay, and as you can see in this picture, magnesium has 2 plus, or it has a 2 plus charge. Okay, and chlorine has a -1 charge. Okay, so magnesium binds to two chlorine atoms so that they can become a compound which is neutral. Okay, but for example in ammonium chloride, okay, which is NH4Cl, and NH4 is a polyatomic ion. We talked about those in my previous videos, so if you don't know what a polyatomic ion is, go watch that video. Okay, and so it has a +1 charge. Okay, and as we know, chlorine has a -1 charge. Okay, and so in conclusion, only one ammonium binds to one chloride. Okay, and so we have one cations and one anion. But in this one, in magnesium chloride, we have one cation, but we have two anions. Okay, so they have a different number of cations and anions. And the environment affects the strength of ionic bonds. Okay, and so for example, in a dry in salt in a dry form, okay, or a dry crystal form, So the bonds are so strong that it takes a hammer and a chisel to break it enough of them so that we can make a crack and break the whole chunk into two little pieces. Okay, or in this case, as you can see in this picture, they use drills. Okay, so even more stronger tools are needed. Okay, but if the same salt crystal is dissolved in water, okay, the ionic bond becomes much weaker because each ion is partially shielded by its interactions with water molecules. Okay, and so a cool fact is that most drugs are manufactured as salts because they are quite stable when they are in their dry form. Okay, so take for example these pills what you take. Okay, any kind of pill is manufactured in this way. Okay, so they are very hard. You can break it, but you can't break it with your own hand in some cases, but when it is dissolved in water that is inside your body, it just turns into smaller, very smaller bits, and when I say smaller bits, I mean into the atom parts. Okay, so we will learn about how salts are dissolved in water in the future videos. Okay, so stay tuned for those videos too. And so another fact is that some elements, okay, have two ions. Okay, for example, iron or Fe can form anions with a 2 plus, no, not anions, cations with 2 plus charges and cations with 3 plus charges. Okay, so remember those. And hi, I have really do have a question for you. Okay, so for example, when we hit a block of salt with a hammer or a hammer and a chisel, okay, why does it break and why doesn't it just bend? Okay, so you can pause the video to think, because this one is a little bit hard. Okay, so I'm telling you the answer right now. Okay, and how might that? Whoever gets this question right, either he is or he or she is a pro, or he or she has watched this video 2 times. Okay, so a few slides back, okay, let me find that picture. We saw, okay, here it is. We saw that the sodium chloride, okay, are positive and negative. Okay, so as you can see, let me get my laser pointer. Okay, as you can see here, chlorine, okay, is negative and sodium is positive. Okay, and so when we apply pressure or hit this block of salt with a hammer or and a chisel, okay, we actually just push these this line, okay, this row of atoms, okay, one row down, okay, or one a little bit down. Okay, so when we push this part down, okay, so the chlorine and this one and this chlorine, okay, they are very close to each other. Okay, so as we know, the charges that are the same repel each other. Okay, so chlorine and chlorine repel each other, and this sodium with this sodium, and all of them just repel each other. Okay, so that repelling makes a force strong enough so that the whole block, or a part of that block gets broken into tiny bits. Okay, and so that was a good question. So I hope you got it right, and if you didn't, no problem, you can just watch me tell you the answer again and again, so that you can be ready for this question coming in your exams. Okay, and so that was all for this video. I hope you enjoyed this video, and so we are finished with the ionic bonds, and so I'll see you in my next videos.